Hey guys, T here's another video. This one's on finding side lengths in trigonometry, obviously for right angle triangles. So in the previous video we've seen that the trig ratios link the size of the angle in a triangle, a right angle triangle, and the length of the sides in that right angle triangle. So they can be used, these ratios can be used to find the length of unknown sides. But that's only if 1. An angle is known, 2. One side length is known, and 3. It is a right angle triangle. So all of this stuff that we're doing, all this trigonometry we're doing so far depends on it being a right angle triangle, and we're going to be using the trig ratios. So the first step would be to label the sides and angle of the triangle like you've been doing before. It's angle of interest, theta, opposite, adjacent, hypotenuse. Find out what's known, then use algebra to find the unknown side. And you're going to be using a trigonometric ratio that involves both the known side, so number 2 here, one side has to be known, and the unknown side. So you need to work out from SOHCAHTOA which of the ratios involves both one of the sides that you know the length of and the unknown side that you're trying to find out. So let's see how that works. Find the length of side x in the triangle below. X is at the bottom there. So 58 degrees here is our angle of interest that we're given. So that's where theta is. 10 centimeters here is opposite to the right angle, so this must be the hypotenuse. So x must be opposite. And this other side that we don't know, this is the adjacent side. So we need to use a trig ratio that involves both the known and the unknown sides. So in this case, it's opposite and hypotenuse. Opposite and hypotenuse both involves the known side and the unknown side. So if we remember the SOHCAHTOA, does tan involve the known and the unknown side? Well, it only involves the unknown, so tan's not going to work. Does cosine involve the known and the unknown side? It only involves the hypotenuse, which is known, and we don't know adjacent, so cosine's not going to work, so it must be sine. So sine of 58 degrees is going to be OH, so that stands for opposite over hypotenuse, so opposite is x centimeters, which we don't know, and hypotenuse is 10, which we do know. So we've set up the relationship. We know the ratio sine 58 degrees is the unknown over 10. And now what I've said in the tips above, calculate what is known, then use algebra to find the unknown side. So there's only one thing we don't know here, x, okay? Everything else we do know. So, and we have to use algebra as well. So, first step, what's the opposite of dividing something by 10? Timesing it by 10. So let's times both sides by 10. X over 10 times by 10. Something divided by 10 times by 10 cancels out, so you're going to end up with 10 sine 58 degrees is equal to x. So we just need to work out what 10 sine 58 degrees is. Like for us, the calculator, as shown in the previous video, can work out what sine of 58 is. You literally just put in sine 58, and it gives me a decimal point, 848,048, and then times that by 10. So 10 lots of whatever sine 58 is 8.4805, and that's the 4 decimal points. So what that's telling us is that this opposite side must be 8.4805 centimeters to 4 dp, 4 decimal points, okay? So that is an example of using trigonometry and the trig ratios to find unknown sides in a triangle below. So the key is that you have to have the angle known, Why do you need to have the angle known? Because you need to be able to work out what the sine, cosine, or tangent of that angle is using your calculator. You need to know one of the side lengths, so you just have to know the length of any one of these three sides, and it has to be a right angle triangle. Once you've got those conditions met, you can use this mathematics to find the unknown side. We might run another example here. So another example, find length of side x, and quickly draw the triangle here. Not as neat because I'm doing it live. X meters on that side, 8 meters on this side, 39 degrees here. So theta is the angle that we're given. So 8 meters is opposite to that. This bottom side here is the hypotenuse because that's opposite from the right angle, and this x must be adjacent. So let's write toa. We need to use one of the ratios, sine, cosine, or tangent, that involves a known side and the unknown. So I know opposite and I don't know. The unknown is the adjacent. So sine's not going to work because that is the opposite and hypotenuse. Cosine is adjacent and hypotenuse, so that won't work either. But tangent will work because it involves the opposite, which I do know, and the adjacent, which I don't. So tan of the angle 39 degrees is going to be opposite over adjacent. So this time I know the top line. I know the top is 8 and divided by x. Alright, so this is going to be slightly different to before, because I'm not just going to times both sides by 10. I need to get x by itself though. So what's the opposite of dividing? Because this side is being divided by x. The opposite of dividing something by x is timesing by x. So we need to times both sides by x. So the left side is going to be x tan 39 degrees, and then 8 on x times by x again. That cancels out. So x times tan 39 degrees is going to be 8. What do we know here? Tan 39. So we can work that out. Tan of 39 is going to be 0.8098. That's the 4 decimal points. And what is x? What is this 0.8098 doing to x? There's a times sign there, so we need to get rid of that by dividing by 0.8098. But if we do that on one side, we need to do that on the other. 0.8098. Those cancel. 8 divided by 0.8098. So x is going to be 9.8, approximately equal 9.8792 to 4 decimal points. So we've just worked out that this unknown side is going to be 9.8792 meters to 4 decimal points. So that's showing the other variation that you might have to do. If you know the top side of the ratio, you need to get x by itself by timesing by x, times both sides by x, cancels on this side, and then you need to divide by whatever tan 39 is on both sides to solve for x. Alright, so that is another example of finding the side length using a different ratio there. Hopefully that helps you out, and I'll see you in the next video.